Hey, Mr. Harridan here. We're going to go over periodic trends here. Okay, so groups, they run vertically down the periodic table. Okay, and trends, which are the patterns such as reactivity and some physical properties, tend to be constant within a group. One of those trends is based off of the number of valence electrons. Since they have the same number of valence electrons, they have similar chemical properties. Periods run horizontally here. Make sure you cross this out. Run horizontally on the periodic table. As you work through the period on the table, trends tend to repeat themselves from period to period. Okay? And these trends are based off of basically two things here. When I look at groups, groups are based off of the number of energy levels. When I look at periods, I look at the shielding effect. Which is the number of protons. If there are more protons and we have the same number of energy level, there is a succussion drawing in of the electron clouds, making things smaller, pretty much is what it is. So we're going to look at atomic size here. Here's the definition of radius here. It's technically the radius that's half the distance measured from the center of one atom to the adjacent of the center of another identical atom. The bulk of this distance is the electron playground. Atomic size decreases across a period, and atomic size increases down a group. Okay? So if you're looking for a pattern here, the largest atomic radius, if you're considering all the atoms on the periodic table, will be Fr, which is called francium. The smallest atomic radius is helium. Okay? Now if you look at the periodic table here, francium is down here. Okay? So if I put francium in the lower corner of my periodic table and helium's up here, atomic radius increases going down. Because you're adding more energy levels, so it's getting bigger. And it increases going from right to left. Because the more protons you get, it draws in those energy levels. Okay? So, which would have the larger atomic radius? Calcium, bromine, or barium? What I like to do is draw them where they're on the periodic table here. So this is my periodic table here. I see barium's down here, calcium's over here, and bromine's over here. So calcium, bromine, barium. Ooh, what am I doing? What are you doing? Barium is at the bottom, calcium is right here, and bromine is right here. Okay, so this is period 4, and this is period 6. Period 4 means that there are 4 energy levels. Okay, so both of these have 4 energy levels. Okay, barium has 6 energy levels. It's kind of like the kid you picture at winter and he puts on like 7 layers of clothes. He looks bigger. If he only didn't put on 3 layers of clothes, then he looks smaller. Okay? So this is the biggest. Now comparing calcium to bromine here. Bromine has 35 protons and calcium has 20 protons. So the 35 protons draws this in, making this the smallest one. So if I was to put this in order from largest to smallest, the largest would be barium, the second would be calcium, and the third would be bromine, which would be the smallest. Okay, that is looking at the size of the atom. Okay, ionization energy. Definition of this. This is the energy required to remove one outer valence electron. Okay? Since 8 valence electrons indicates a full outer shell, S&P levels, the closer the number of valence electrons is to 8, the more difficult it is to pull away an electron, meaning it will have more ionization energy here. Ionization energy increases across a period, and it decreases down a group. Okay? So if I'm looking at elements here, the lowest ionization energy, okay, I should write out energy so you know what I'm talking about here. The lowest ionization energy here would be francium. It is the easiest to remove an electron from. The reason why is it's so big, so it can't protect that outer electron, so it's very easy to take it away. The highest ionization energy is helium, because it's the smallest atom we have. So if I'm picking ionization energy here, here's helium up here, right? Ionization energy increases going up a period. And it increases going left to right across a period. So it increases going up the group. I don't even know if I could place a group there. And ionization energy increases across the period here. Okay. So, which would have the highest ionization energy? Calcium, bromine, or barium? Okay, so we're looking at the same three elements here again. So this is barium, this is calcium, this is bromine. Okay. This was period 6 again, right? And this one was the biggest because it had 6 energy levels. And it has 2 valence electrons. Okay? Calcium has 4 energy levels because it's period 4. And so does bromine, which doesn't tell me anything. Then I look at the number of protons again here. Calcium has 20 protons. Bromine has 35 protons. So it draws in these electrons, making this a smaller radius. And if it's a smaller radius, it's going to be harder to pull around the electrons because bromine has 7 and calcium. Why did I? Calcium has 2. Stop rushing, Mr. Harrod. Come on. So the highest ionization energy here would be bromine. The next would be calcium. And then finally, barium. Since it has the lowest ionization energy, it is the easiest one of these 3 to take an electron away from. And remember, you want to try to pick metals for the lowest ionization energy, because metals lose electrons. Non-metals tend to gain. Now let's look at the opposite property here. Electronegativity. is a key definition. Okay? This refers to the attraction a pull an atom has to a nearby electron. This is the tendency to gain an electron. Okay? Closer atom is to 8 valence electrons, the higher electronegativity, because all atoms want to try to get to 8 valence electrons. Okay? So, electronegativity increases across the period. Electronegativity decreases down a group. Note, noble gases do not have an electronegativity. They already have 8 valence electrons. So we do not consider electronegativity when we are doing noble gases because there is no tendency to gain an electron. Okay? This is why they're called inert, meaning unreactive. Okay? So the highest electronegativity is for fluorine, which has a value of 4.0 according to Linus Pauling. The lowest electronegativity should be, you guessed it, my friend, francium. Okay? So if we're looking for a pattern for electronegativity here, okay, we have fluorine here. Electronegativity increases, going up a group, and it increases electronegativity increases across a period. So again, if we're looking at calcium, bromine, and barium here, barium is here on the periodic table, calcium is above it, remember, and bromine's over here. Barium has 6 energy levels. Calcium has 4 energy levels. And bromine has 4. Electronegativity is the tendency to hang on to electrons. So the smaller it is, usually it's going to have less electronegativity. It's going to have more electronegativity. These both have 2 valence electrons because they're in group 2. And bromine has 7 valence electrons. This is the one that is closest to getting to the 8 valence electrons here. So the highest electronegativity is bromine. Then comes calcium, and then barium would have the lowest electronegativity. So to summarize the periodic trends here, okay, we have a periodic table here. This is francium, this is fluorine, and this is helium. Okay? If we're going down and right to left towards francium here, atomic radii, ionic radii, and metal reactivity increase towards francium. I always say aim for francium because it's atomic radii, ionic radii, and metal reactivity. Okay? Now, non-metal reactivity ionization energy and electronegativity increase towards fluorine. So if you're going up a group or left to right across the period, it increases towards fluorine. Now, remember, ionization energy, really the highest is helium. Okay? Remember, noble gases don't react. Zero electronegativity. Okay, I have to go over one more concept really quick in this video. Explaining the difference between atomic radii versus ionic radii. Okay. The example I'm going to look at here is going to look at C0, which is the atom. I'm going to look at C minus 4, which is the anion. And I'm going to look at C plus 4, which is the cation. Okay? This one over here gained electrons. If you gain electrons, you make a larger radii, because you are adding to your energy levels, making them go bigger. Okay? If you lose electrons, you're going to have a smaller radii, because you're taking away from electrons from the energy level. Okay, guys are champions. The legend is out.